Hey guys, today we'll be working on problem 16 of the new 2025 AMC8. So 5 distinct integers from 1 to 10 are chosen, and 5 distinct integers from 11 to 20 are chosen. No two numbers differ by exactly 10. What is the sum of the 10 chosen numbers? Well, let's see. This problem is very simple and very straightforward. Well, one way we could solve it is we just use an example. If we choose 5 distinct integers from 1 to 10, let's just choose 1, 2, 3, 4, 5, and now we have to choose something from 11 to 20, but they cannot differ by 10. So it cannot be 11, it cannot be 12, it cannot be 13, cannot be 14, cannot be 15. So there's only 5 numbers left to choose, which is 16, 17, 18, 19, and 20. So now we just want to find the sum of these numbers. Let's write them in a row. We want to find the sum. So this is 21, this is 21, this is 21, 21, and 21. So 1, 2, 3, 4, 5. There are 5 groups in total of 21. So this is equal to 105. So it's just answer choice C. Hey guys, today we'll be working on problem 17 of the new AMC8 2025. So in the land of Markovia, there are 3 cities, A, B, and C. There are 100 people who live in A, 120 people who live in B, and 160 who live in C. Everyone works in one of these 3 cities, and one person may work in the same city as they live in. In the figure below, an arrow pointing from one city to the next is labeled with the fraction of people living in the first city to the people who work in the second city. So how many people work in A? So let's see. Let's take a look of the arrows that point towards A. These are the arrows that show. So this one right here, this arrow shows the amount of people who live in town B but come to work in city A. And this, let's use a different color. This blue arrow shows the people who live in town C but come to work at town A. So first let's calculate these amount of peoples. So first let's label them actually. So in city A, 100 people live in city A, 120 live in city B, and 160 live in city C. So let's follow this red arrow right here. So this means 1/3. So 1/3 of the 120 people who live in city B come to work at city A. So 1/3 of 120 is 40, and this blue arrow right here is 1/8. So 1/8 represents 1/8 of the people who live in city C that come to work at city A. So 1/8 of 160 is 20. Now let's find, so this right here is 60 people so far, but that's not exactly right yet. We have to account for the people who both live in city A and still work at city A. So let's take another color. Let's take this green color. So we have 1/6 or 1/4 that go out to work in city B and 1/5 that go out to work in city C. So let's count. So 1/4 of the total 100 go to work to city B, and that is 1/4 of 100 is 25. And 1/5 of 100 is 20, so 20 go to work in city C. But we're not trying to find these values. We're trying to find how many stay in city A. So we have to take 100 minus 25 of the people that go to work in city B and minus 20 people that go to work in city C. Well, this right here is basically minusing a total of 45. 100 minus 45 is equal to 55. And we also have to account for the other 60 people that come from different cities. So 55 plus 60 is equal to 115 people in total. And this would lead to answer choice D. Hey guys, today we'll be working on problem 18 of the new AMC8 2025. So the circle shown below on the left has a radius of 1 unit. The region between the circle and the inscribed square is shaded. In the circle shown on the right, 1/4 of the region between the circle and the inscribed square is shaded. The shaded regions in the two circles have the same area. What is the radius r in units of the circle on the right? Well, let's take a look. So the radius of this circle right here is 1, and we're trying to find what is the area of the shaded region. Well, one thing we can notice is this is half of the diagonal here. So we know that the area of the full circle is pi r squared by the formula, and the radius is 1, so the area is just pi. Well, one thing we can notice is that if we draw both diagonals here, it makes a 45, 45, 90-degree triangle right here with these two sides being 1, or we could just straightforwardly use the Pythagorean theorem, so we know this side length is √2. So now the area of this whole square, this square right here that's colored in, is going to be √2 times √2, which is 2. So the region of the shaded area is the region of the circle subtracted by the square. So this is pi minus 2. So we know the whole region here is pi minus 2. So one of these is pi minus 2. Now if we want to find, let's say we want to find this green part, this green part, this green part, and this green part all added up, we do 4 times pi minus 2, which is 4 pi minus 8. And 4 pi minus 8 is basically the area of pi r squared minus r √2 squared. Let's try to understand where this is coming from. So the pi r squared basically comes from the area of the total circle, and this r √2 squared is the area of the square. So when we subtract it, we get this. Well, we can notice the only term that has pi in both of these is this. So we know r squared is equal to 4. So r is the square root of 4, hence 2. So if this is 2, this is the radius. But let's just check real quick to make sure it works. So if it's 2, then the total area of the circle would be 4 pi. And then this side length would be 2 √2. And 2 √2 squared is 8, so it would be 4 pi minus 8, which is equal to our desired amount. So we know the radius of the circle on the right is 2, which would be answer choice B. Hey guys, today we'll be working on problem 19 of the new AMC8 2025. So two towns are connected by a straight road, 15 miles long. Traveling from town A to town B, the speed limit changes every 5 miles, from 25 to 40 to 20 miles per hour. Two cars, one at town A and one at town B, start moving toward each other at the same time. They drive at exactly the speed limit in each portion of the road. How far from town A in miles will the two cars meet? Let's draw a diagram of what's going on in this problem. So let's say that's the road, and we have town A here and town B here. And the total length of this road is 15 miles long. Let's cut this road into 3 sections, each of 5 miles. 5, 5, 5. This is 25 miles per hour is the speed limit. This is 40 miles per hour, and this is 20 miles per hour. And let's see. The question is asking, say the cars meet right here. How far is this point from town A? Well, let's see. Let's use our formula. Distance is equal to rate times time. One quick and easy way to remember this is dirt, and we convert the I just to a equal sign, so distance is equal to the rate times the time. Well, let's look at the car that starts at town B. How long will it take from for this car to go from here to the end of this speed limit range place? How long will it go to travel for 5 miles? Well, let's see. The distance we want it to travel is 5 miles. The rate it travels at is the exact speed limit, which is 20 miles per hour. So 20 times t. Let's divide by 20 on both sides to find t. So t is equal to 5 over 20, which is equal to 1/4. Well, this is basically 1/4 of a whole hour. So 1/4 of an hour is 15 minutes. So it takes 15 minutes to drive to the end of the range. Well, let's take a look at the other car. How far will the other car travel in 15 minutes? Well, let's notice one thing. We cannot just plug 15 minutes into the distance equals rate times time formula, because we know it will travel further than that, and it will have to go to the 40 miles per hour range because it travels faster in this range. Well, let's see. Let's first take a look at how long it will take from the car that starts here to get to the end of the 25 miles per hour range. So the distance we want it to drive is 5 miles. Let's actually do it over here. So it's 5 miles, and the rate that it's driving at is the speed limit, 25, and t. So let's divide by 25 on both sides, and is equal to 1/5. 1/5 of an hour is 12 minutes long. So if this is 12 minutes long, then we need 3 more minutes to get to a certain place right there. So say this takes 3 minutes long. We want to find how far it's going to travel in these 3 minutes, because we want to find how far it travels in 15 minutes at the same time this one does to here. So in 3 minutes, let's plug it into the distance times rate. Distance is equal to rate times time formula. So the distance is unknown. That's what we're trying to find. And the rate it's traveling is now 40 miles per hour because it has entered a new zone. So 40 miles per hour, and the time, we know it travels for 3 minutes because that's what we're trying to predict. Well, 3 minutes is basically 1/20th of a whole hour. So let's do this. So the distance is 40 over 20, which is just 2 miles. So we know this little part right here is 2 miles. Now let's draw a diagram of where they are now. So this is the road once again, town A and town B. So let's split it up. This is 5, that's 5. So far it has traveled 7 miles. This is 25 miles per hour, 40 miles per hour, and last one, 20 miles per hour. So far it's traveled 2 miles in the 40 miles per hour range, and this one has traveled to the end of the 20 miles per hour range. Well, let's see here. Now that they're both traveling in a 40 miles per hour, we know that it will meet in the exact middle of however long this is. Well, we can actually calculate how long this is. So the total range of the whole road is 30 miles long. No, it's actually 15 miles long. Yeah, 15 miles long. And then minus that, we've driven 7 miles, and we've also driven 5 miles. So 30 minus the total 12 is, there will be 15 minus 7 plus 3, so this is 3 miles long in between. We know that these two cars are going to meet in the exact middle of these 3 miles. How do we know this? Well, they're both driving at the same rate towards the center, so we know they're going to have to meet in the middle. So this is 1.5 miles, and we're trying to find how far this is from town A. So 1.5 plus the 7 miles we've already traveled is 8.5. So that would be our final answer. So this would be answer choice D. Hey guys, today we'll be working on problem 20 of the new AMC8 2025. So let's see, the problem says, Sarika, Dev, and Rajiv are sharing a large block of cheese. They take turns cutting half of what remains and eating it. First, Sarika eats half of the cheese, then Dev eats half of the remaining half, and Rajiv eats half of what remains. Then back to Sarika, and so on. They stop when the cheese is too small to see. About what fraction of the original block of cheese does Sarika eat in total? Let's get a sense of what's happening in this problem. So let's abbreviate here. Instead of Sarika, Dev, and Rajiv, let's just say S, D, and then R. So let's see. First, Sarika eats half of the cheese, so she eats 1/2. Dev eats half of what remains. Well, there still remains 1/2, so it's 1/4. And Rajiv eats 1/8, because that's half. And this goes so on, and they divide by 2 each time. Well, let's see, what does the question ask? The question asks, how much of the original block of cheese does Sarika eat in total? So we're focusing on only S. So the next time she eats 1/16, which is half of 1/8. So let's see. About what fraction does she eat in total? So we're trying to find the total, which is the sum. Well, it also says when it's too small to see. That's basically saying this goes on forever and ever and ever. So Sarika eats 1/2, then 1/16, then, well, let's see, what's a pattern here? Each time this is dividing by 8. So the next time she eats would be, this is 1/2, this is 1/16 is 2/4, and the next one is 1/2/7, and then 1/2/10, and so on forever. Well, let's see. One thing we can notice here is this is an infinite geometric series. What does that mean? Well, this means the sum of this is just goes on to infinity. Well, if you remember, the formula for finding an infinite geometric series is the sum is equal to the first term over 1 minus a common ratio. We can also solve this by just setting this to S, and let's do this way first instead of using the formula. So we set this whole sequence, the sum, to be S. Now we have S/8 is going to be equal to 1/2/4 plus 1/2/7 plus 1/2 to the 10th, and so on forever. Now let's subtract these two equations. Well, let's see, what's S minus S/8? Well, S is basically 8S/8, so this is 7S/8 is equal to 1/2. Multiply by 8 on both sides, so 7S is equal to 4, and S is equal to 4/7. So the sum is 4/7. But we can also plug it back into the equation. The first term is 1/2. 1/2 over 1 minus the common ratio is divided by 8, so it's basically multiplying by 1/8. So that, and then 1/2 over 7/8 leads us back to the same answer, 2/7. So this would be answer choice A.